this to be allowed to go to school back.
Welcome,
Brian,
panelists.
Your audio is working.
Yeah, do you hear me okay?
Yep.
Great. All right. Well, so this should kick off in a little bit. We'll just kind of a open conversation here, just topics, whatever you guys want to talk about amongst each other. Unfortunately, we have a few FDS developers here, so it's kind of just me and Dave. Stacy, as the outsiders, you probably have all kinds of internal conversations that are interesting, but maybe we'll bring up some of those points and just in general, where you think fire modeling's going, where you would like to see improvements in the industry, you know, anything that you see, topics of interest. And we have a few kind of little seed topics if the conversation gets stale, but we'll just wait for people to kind of show up. It looks like we have about 60 people in the session already, so which is a pretty good number. So I think, I want to thank Eric for jumping in while I was finishing up the Q&A to let you guys in. So we have a first question here, also just kind of answering questions from people in session. So is there a plan to release an ARM version of FDS to support that platform? Somebody has some fire engine. Okay, sorry, that was in the background through my back channel in Manhattan. The fire trucks are going by, so I got that back here.
Do they mean AMR or?
I think it's ARM, like the ARM processor, like instead of x86 for the Intel processors supporting ARM.
So the last release that we've made, the last official FDS release, we set some parameters to enable the calculations to run on AMD machines. So far so good. We haven't had any more complaints from the people who were originally complaining. It was basically a class that Fred Maurer was teaching, and a few people in the class had new laptops with AMD chips in them, and they were having trouble running FDS. Changed a few of the Intel environment variables, and things now seem to be working.
Yeah, and I think ARM is a little bit different than that in a way. I think you would have to use a compiler like targeted for. Right now, you're building x86 type.
Okay.
The x86 type platform, which is like Intel chips and AMD chips. ARM is like a different architecture, more typical on like mobile platforms or RISC computing and some other other side. Mm-hmm.
Yeah, I think that sort of thing is a good job for a third party like Thunderhead.
I don't know
to provide that service.
But it could be. I mean, I think it would be much like you're using the Intel compilers now. You would just have another set of compilers for that ARM or some features for ARM architecture.
It is burdensome with the limited resources we have to support lots and lots of different versions of FDS. I mean, the source code's out there. If you have specific machines you want to optimize the code for, you have the make files and can do that. I mean, if something like an ARM machine becomes a major player that it overtakes the x86 architecture, we probably look to make that the default.
Mm-hmm.
And how we work with that winds up being all the machines that we're dealing with. But it's to say, why don't we have a GPU version or this version or that version? We spend all our time supporting these versions and not doing development. And there's only the handful of people you see here on the screen.
Right.
None of us are devoted 100% of our time to.
Yeah. Right. And a lot of times, these things that people suggest, like CUDA, these are things that they've heard about, or they see that someone at a university has written some kind of code that works well in this language. A lot of times, you have to completely restructure everything. So at the moment, we're just going to try to maintain, FDS on Windows, Linux, and Mac as best we can. And we look for volunteers who can take the repository, clone it, and try out these various other alternative strategies. I mean, if someone said to me, hey, we can run FDS 10 times faster if you do this, that's going to get our attention.
Right.
However, if they say, yeah, we implemented this stuff and FDS runs about the same, that's not really going to get our attention.
Yeah, I was going to say, actually, I think quite a few years ago when I was in Maryland, I compiled FDS for the PS3 to run it on the PlayStation to try to do a little cluster of PS3s. And I think at the time that was an ARM. I just used GCC and compile for that architecture. So I believe it's possible. And I think Lucas is coming in saying you can do that through GCC. So yeah. I was going to ask if there's any other, I guess, technological interests or breakthroughs or anything coming up kind of down the road with new. I know there's quite a bit in the cut cell method with the immersed boundary method and all of that. Are there any other infrastructure or big capabilities you kind of have in the works?
I think, as I just described in my talk, I mean, this wildfire application, I mean, there's a lot of, I don't want to use the word pressure, but let's just say a lot of motivation at NIST to address the wildfire problem. Right? In the United States, it's a problem that's not going away. So we're devoting a considerable amount of attention to it. And what I'm hoping is that the most recent version that we've put out, can start doing some of these level set calculations. I'm really interested to see if the user community, one, can just do it, right? I mean, this the first thing you want to know is, okay, can people actually do these kinds of calculations? And if they can, give us some feedback on what's working and what's not. I'm still somewhat frustrated because a lot of times people, grab the latest version or even, our development versions, and they do all sorts of great stuff with it, and they don't let us know. And they think that it's mature. A lot of what we put into FDS is meant to evolve. And so the feedback that we get from a user about something not working, that will often, completely reset our minds in the right direction. We need that feedback. So I'd like to see how easy or hard these wildland calculations can be.
Yeah, no, that's a good point. And I think that's a missing link in almost all of the industry is that feedback loop, getting that regular open dialogue started.
Right.
I was going to ask a question too, and it came up here. I did pin Randy's comment to the top here, just with the FDS roadmap. So a lot of questions about what's coming and where you guys going and all of that stuff. Thanks, Randy, for pinning that link up there. There's some more, I think, user questions here. One is just about how do you determine cell size of mesh, and is there a guideline or whatever? And I do want to mention that that's also in the FDS users guide. There's a D star over DX. I think one thing that's typically missing from that is, and it came up with one of Randy's comments with the window flow equation or calculation, and they based on D star over DX, but the interesting variable was actually flow through a window. It wasn't resolving the fire as much as resolving this flow. And so, and sometimes we give a lot of guidelines like, well, you need at least 4 cell width to get, minimum resolution of an opening and some stuff like that. So I think that maybe, is there any other points of clarification or anything on not just cell sizes for resolving the fire, but resolving a flow appropriately through an opening or just in the flow field, like for HVAC vents or anything like that, if you have any advice.
Yeah, I mean, I can jump in here. I mean, generally speaking, anything that you want, any motion that you want to resolve needs 10 to 20 cells. Any length scale that is of importance in the problem to actually resolve the signal, like in terms of the CFD, in terms of getting a good solution to the equation, needs that many cells. Now, in practice, we run into this issue all the time. Okay, if you're going to actually resolve the viscous length scale in a boundary layer, you would need to do a DNS, and obviously we can't do that. So that's why all these wall models and so on come about. But until such a time that a model exists to deal with something, the example of like two-way flow through the window got brought up in an earlier talk, then you need to resolve the flow. I mean, there are, this is one of the reasons why, and Jason can jump in here, developed the two-way, HVAC model was so that you could have sort of a subgrid model for a window if you that had two-way flow. But until you apply such a model or something like that, you need to assume that you need to get 10 to 20 cells across that area of activity if you expect to get the physics right.
Okay.
Yeah, I'll just jump in. I think for, what Randy's hinting at, I think, is that, it's as you're a new user to FDS and trying to gain experience with the models, I mean, you need to be looking and trying, the impact of grid size on things like, if flow through the doorway is the most important thing you're trying to get in your calculation, do a calculation where you start the fire immediately at the largest size and see the impact of grid on doorway flow. You'll quickly be able to understand how many cells you need to get, a good enough answer. And again, good enough might depend on what it is that you need the calculation to do. And then there's always, the thoughts of, if you do have openings that are very small, we did have, this localized leakage HVAC model, which allows you to some extent capture flow to, openings that you're just not going to resolve with any reasonable grid size that you can afford, using the HVAC model. And the Bryant hydrogen or helium rather cases in the validation guide are a good example of that.
Yeah, and we have a little tutorial on excuse me, the PyroSim tutorials on our support site that have a few different examples of using like bulk leakage, localized leakage, and some demonstrations of those in addition to what's in the manuals. So those might be a good reference if somebody's looking into that. I brought Simo in here and asked him to join because and Jason actually are good people to have in here for this. And there's a comment here about just I think part of it might be a little bit of a not understanding all the capabilities, but also just I think a good question, which is, can you please resume the options for the fire spread modeling? I believe that the official way is to prescribe A and E coefficients for the material. However, those are quite difficult to find. What do you think about simply providing the ignition temperature for each item? I will say that's already a capability. You can just define a heat release rate per unit area and an ignition temperature and have the item burn. So that's a capability you have, but it does point to a complexity. And I know this has kind of been an ongoing complication, which is how do you get good data for your solid phase solver for the pyrolysis model? There are a few test methods like TGA and DSE. Are there methodologies or good standards that we can, put a piece of material into and get good data out of?
Yeah, that's very good.
Jason, why don't you describe, Jason, what you did recently in terms of like mimicking a cone calorimeter?
Yeah, one of the things that we've recently added is the ability to take data from a cone where you have some mass loss based on some incident heat flux, and then have FDS scale that curve, shrink or expand it according to the current, flux that FDS is predicting to the surface, so that you still get the total integration of mass correct, but it, roughly approximates the impact of cone heat flux. But putting on sort of my, fire protection engineering hat, I think if we're in the realm of doing design problems, I'm not sure we're in a spot where we should be predicting fire spread in objects because we don't know what the fires are going to be in our buildings, right? Especially when we're designing fire protection systems over, a 50-year lifespan for a building. I don't think we have any business predicting fire spread. We should be using some kind of design fire that represents the hazard we expect to exist over that lifetime. Now, if you're in the realm of litigation or trying to reconstruct the fire scene, then maybe you need to try and look at using fire spread. And there, it's definitely challenging. I think we're a ways from being able to really do that reliably for the complex three-dimensional combustible objects we have in the real world without relying on some kind of small scale testing, to drive those models. I think that this to be able to figure out what's the A&E you should use for, a fiberboard desk with a melamine top. I think that's going to be a tough problem to crack for a while.
Yeah.
There is a project that's, I wouldn't say sponsored, but kind of through the IAFSS to develop a database of material properties. So this is what's called the so-called MAC-FP, modeling and computing. What's the whole thing?
Measurement and computation of fire phenomena.
Glad we had you here.
MAC-FP, that just rolls off your tongue.
I told them at the beginning that it was a.
But anyway, I mean, they're just kind of kicking off the solid phase effort. But the idea is that, down the road, participating labs can, push up data for various materials to, a GitHub site, and they're going to develop through this collaboration, software tools that will take that raw data, TGA, MCC, and so forth, and spit out the kind of properties, the A and the E and so forth that you would need in fire models. That's kind of been a dream for a long time, but it still hasn't really materialized.
Yeah.
Stimo might be
part of that process. Yeah, if I continue here, being part of that MAC-FP condensed phase group, I wouldn't really expect to have a great database of materials after this 2 years or what. We are still working with PMMA, right? But
love PMMA.
Yeah. But what I already see that we are going to learn a lot about how the different experimental methods, first of all, how much they're scattering in the experimental data that we get from different labs, and then we are going to see how the different methods of obtaining these A and E's and whatever numbers we need, how they work. So it's more of a learning process than making a database, I would say.
Right,
and making the tools to process.
Okay, so what I see, Stimo, is if there was a fairly robust script that would take data that you've collected from the bench scale apparatus and then produce these parameters that one would need to put into a fire model.
Right.
I mean, I think that would be huge because, as Jason mentions a specific thing that you might be interested in for an investigation. Well, that you're never going to find that in any kind of database because there are an infinite number of things in this world.
Right.
But if you were able to go to a testing lab, run those basic tests, and then use the scripts that you guys develop to boil down or convert the raw measurements, bench scale measurements, into the parameters that are needed in fire model, I think that would be a success.
Yeah, and I did want to mention too, Lucas brought it up here in chat, but there will be a talk using that data on Friday. So tomorrow there's a talk about that, the use of that. And I wanted also just to mention, we have Dave Stacey in here. So he's, an FEE who's working in the industry. And, David, if there's any thoughts or questions you might have of the group about your work or what would make things better, or if you have any of that, I welcome you to chime in on that. Has anything come up for you as we're going here?
No, this is great. This is all interesting stuff. What I'm getting out of this so far is all about sensitivity. A large part of my work is, and most of my analysis, I have to consider, extensive sensitivity, whether it's an atrium smoke control, where, as we were talking about, developing flow fields through natural makeup air openings, exterior temperatures, summer, winter. And then likewise, when we're talking about flame spread, let alone the sensitivity in a more basic smoke control model, once we start looking at flame spread, those variables just, exponentially increase where there's so much room for variance. So that's the only thing I would drive home so far with our discussion is, as you're doing these types of analysis, really set up a nice sensitivity approach where you these variables, you alter your cell sizes, you alter your A, your E values, and see how that affects your output.
David, do you typically, if you're doing an analysis, does for lack of a better term, the AHJ, the authority having jurisdiction, or whomever your sponsor is, do they often give you the range of parameters that they want you to explore, or do they expect you to do that?
Very few. There's a couple. There's several strong AHJs in Texas and California who say you will use the ash rate data for summer and winter and wind. You will use Contam for stair press and elevator press. You will use FDS for this type of analysis. But for the most part, and really that's a big internal push by me, is really education to AHJs. Fire modeling in the States, I know we have a lot of European and foreign attendees here. And in the States, fire modeling is definitely lagged behind. It's a big education push from what I'm seeing. There's some that are very comfortable where they could even take our design brief and our rational analysis, and maybe they have an FTE on staff and they review it in-house. More often than not, they're bringing a third party in to review our work, or we review others. And to that point, furthermore, they're surely not saying, okay, did they look at sensitivity? Did they evaluate different mesh size? They just don't know those details. So it's kind of the risk, and how quickly this could spread out there and have an invalid analysis.
Mm-hmm. Yeah, that's a good point, and thanks for that. I was going to ask with Randy, and maybe this is something we could put together after this, but I know that in the back of the FDS Users Guide, there's a bit about quality metrics and using some of these, like the wavelet error model and the MTR and some of these things. Is there a good sort of a recommended approach to using some of those parameters to then use in part of a sensitivity to study, to use those as the metric? Often we look at, well, when's the heat detector activate as the important characteristic or quality that we're looking at, but what if we were using some of these other tooling, these other qualities like error in the turbulence or transport or scalar transport or something? So do you have any recommendations on that, or is that something we can put together later?
So, I kind of sometimes wish I had never gone down that road of putting these these error metrics in, because I was fresh out of working in a turbulence group, and that's all we thought about. But the main motivation for thinking about those kind of metrics was, could you design an AMR code, an automatic mesh refinement code, that would by itself kind of converge on the right local mesh resolution. They were not really intended as a way of initially saying, yeah, this is good enough. I mean, if you don't have mesh, if you do a sensitivity study with the grid resolution and things are still changing on you, then what good was the error metric? And that metrics they may be interesting from an academic point of view, but I still think that the 10 grid cells across your length scale of interest and doing a good mesh sensitivity study are the best tools in your toolbox. So those are the kinds of things that are still in the code. And there are ideas that are out there that I would, some of the researchers might be able to help us identify, yes, this metric works very well and under these conditions, but I'd say those are still sort of in the research.
Okay, fair enough.
Yeah, I'd like to reiterate that a lot of times, people use FDS for master's level or PhD level theses, and these are the kinds of things that might be useful or good subjects. But if one embarks on that kind of study, let us know, because sometimes, as Randy said, he put those things in 10 years ago maybe, and we really haven't exercised them. So we probably have to refresh them a little bit, take another look at them, work with the student to make sure everything is working fine. And then, if that student comes up with some simple technique that people can use, that would be great.
Mm-hmm. That's great. And there's a little side chat over here about just when doing wind engineering or impact and kind of how many diameters upstream and downstream, kind of some of those questions. So thanks for answering those in chat here. And are there any other, I guess, topics of interest or requests from the community that any of you guys have that would be helpful in your work? Yeah.
Brian.
Sorry, I answered Brian Hardiman in my ear. Let's go ahead.
Yeah.
Go ahead, Simo. Sorry.
Yeah. So last spring, I was involved in this study about the COVID-19, like the aerosol spread calculation. And obviously, FDS is the only CFD tool that I have been using for the last year. So I used FDS to study the aerosol spreading, and I would be curious to hear in the audience if there have been similar projects. The main kind of thought that I had in that project was that it could be very beneficial if we start to think about fire safety systems as kind of synergistic with other safety measures. Like, can we use, for instance, smoke ventilation for providing higher ventilation rates in case of pandemic or something? And it would be really nice to hear about projects where they use CFD and the experience from fire to think about aerosol spreading. By the way, the input files that we used for the publication, I will now post the link to the GitHub site that provides the input files for those scenarios.
Yeah, I think one thing we've thought about with that, just from our Pathfinder modeling, because we did implement some social distancing and some other measures there, but one would be a moving source of some supply then, or some point source of supply of aerosol, something that's aerosolized that we can then trace through the environment in an FDS simulation, sort of as a post-processing of here's the movement and now where do all the gases go, and looking at influence of that. So if there was a way to move a point source through time and emitting as it moves, that might give us that ability to take our XYZ position of the agent and then have that be a source emitter in the FDS simulation.
I mean, it seems to me, Simo, that the next logical step in the kind of study that you did is to not only look at a single individual coughing, but a room filled with children, in a schoolroom, all talking and laughing, and the teacher standing at the front, and you have a vent and you have a window open, because where we are, a lot of parents are concerned about sending their kids to school because they know that the ventilation in a lot of these schools is terrible. These schools were designed in the 1960s. They were designed not to have the windows open. How many air changes per hour, who knows? I mean, I'm sure that people are doing it, but that's the next logical step.
I think there are these kind of classical models that assume that the space is perfectly mixed, and then they basically accumulate the concentration over time, and that's very well known and old stuff. It's available for this type fairly small spaces. The interesting applications for CFD are in large spaces where the fluid cannot assume it fully mixed. The concentrations are very different depending on where the emit version actually is and how it's the background turbulence. And when I was doing the FDS calculation of that, I noticed that there's a lot of kind of things that are different from what I'm used to in the fire. The buoyancy sources are very small. All concentration, everything is very small. So even doing the post-processing was difficult because all the concentrations were e to the minus something. Super small. I couldn't make them visible with MoQ. So
I want to jump in here before there are a couple of things going on and before the idea gets stale. So Brian mentioned this idea of having a device follow a certain path, and therefore it could then. So this works in FDS now. So Jason added the ability for devices to follow a ramp, and this the whole point of that was actually so that device could act as a human, and the human could be like moving through, like trying to exit a building, and you could get like the local concentration and time histories of the smoke concentrations and temperatures and so on. So that can be prescribed right now as a target and measured. So if that's not getting used, I'm not sure how widely publicized that is.
Yeah,
been.
I didn't know about that. So that's actually really interesting.
But what about as a source?
And then it can be a source as well.
It's just a device, so you can
It's
just
a device,
ramp the
so it
X,
can
Y,
be
Z
a
position
measurement
up.
device, or it can be a source, or whatever, and
Okay.
that should all work.
Okay.
It probably needs to get exercised, but I think, yeah, I mean, I think Ruggiero was and Luverio in New Zealand was going to use that for looking at possibly was going to use that to model like car exhausts, for example, on the and look at dispersion from car exhausts. Anyway, so that was that's in there. Let's see. There was also another comment. Varchek had a comment about introducing a mean age of air model through a passive scalar. So you can introduce passive scalars into FDS now. Again, something Jason has added. I don't know that we've ever done it just as a tracer. So that's again something we could exercise and
I basically
and play
asked
with.
this very similar question on the discussion group the other day. At very like this residence time or air, sort of like air
Right,
stagnation
and that is
like that. So
it's a little bit tricky to do that, but we could play around. I mean, yeah, to the extent that you have a passive scalar in your simulation, you know how long, you have to correlate, the local concentration of that scalar with how long it's been in the domain, and you can get a residence time. But anyway, people don't use it very often, this passive scalar idea, but it's been coded up for a while, and it just, I don't think, has gotten exercised.
Yeah, I think the point should be made that often in our work, and we're often not only just doing FDS development, we're actually using FDS for COVID studies, and Jason has his consulting with Jensen Hughes, and we need some feature for a particular job, and we're busy with the job, we put the feature in, we document it, maybe we write a verification case, and then we move on because it solves our problem, but it may not be something of general use. But if someone wants to take that little bit of an idea and run with it, that's great. I mean, we love to work with people who take our small ideas and make them grow, because if there's no interest in something that we put into FDS, we're probably not going to work on it. If it solves our little problem, then we'll just leave it at that. So it's only when we see that there's a general interest of the community that we'll continue working on something and developing it.
yeah, that's a good point. And I think part of it is probably the best way to track these little bumps and changes. Reading through the source code is one thing, or looking at your release notes or changelog, that kind of thing. But it's maybe sometimes hard to tease that out. So we'll have to be a little more diligent.
We don't have a good mechanism for saying, "Hey, I just put this neat thing into FDS." Sometimes we're afraid to do that because what we put in is only a very specific use, and we worried about it being used in ways that we didn't anticipate.
Yeah, it's like, oh, now I can do that. Cool. Now I'm moving cars.
Yeah, exactly. The traveling car problem.
Right. Well, that's good. I mean, that'll definitely be something to follow up on. We have about 5 minutes left before we go to the end here. So just some commentary about this with this passive scalar idea could have a second life with COVID. Maybe that was the point, assessing how long potential viral contaminant was living in the air and was persisting over time or something like that. So that'll be interesting to look at some of that. Yeah, Wojciech saying Jason needs to do press conferences whenever he adds things. Yeah, upload to your blog or your YouTube channel or something like that. Yeah, probably all of you. Yeah, we need a FDS development YouTube channel and or Instagram or something where you guys.
Well, you guys can just
post
do
your
a conference like this once a month, and we'll show up.
Hey,
and
you know, we're thinking about doing these a lot more often. So now that we know how it works, yeah, we've been kind of thinking now that we've had this experience, maybe doing an annual, you know, virtual event like this, and maybe every other year doing a in person or something. So, you know, trying to keep these lines of communication open a little bit easier to participate in. It's hard. We were going to do this in Brno, right? And it's like, how many people can take the time off, fly there, get a hotel, you know, there's the barrier to entry is pretty high. But with this, it's like, get a ticket and show up and, you know, maybe stay up late in the night or get up early in the morning, but you can be a part of it and watch it after the fact. So, but we miss out on all the delicious beer and Prague, so, and the sites. Yeah, somebody else here is just with a question about further development of HVAC. Can it be possible in the future to model complex ventilation systems with fire using PyroSim? And I think you can do a lot of that now. I would recommend that you kind of take a look at the existing feature set. And if there's something missing from the complexity, you know, something that you're not able to capture, give that feedback to the FDS development group, see if there's something in the submodel that can be added. And probably FDS can do even more than PyroSim, right? I mean, we have a very limited set of features that are common, and you have to do a lot through advanced records and even with HVAC. So, you know, there's control systems and other stuff you can do that we just don't have UI for. So, anyway, go ahead.
Brian, I was just going to say before we get out of here that I had posted the FDS roadmap, and the point is that was recently. It's pretty up to date. Sometimes that gets a little bit stale, but which we admit, and try. But this has been gone over recently. So, you know, if you see anything there you'd like to work on, please let us know. If there's something that's not there that you would like to see there, also, you know, you can either send us an email or add it as an issue, a feature request or something like that. I mean, that roadmap is not. The small group here doesn't expect to get to everything on that roadmap. We're kind of hoping that the community can help us kind of fill in some of these blanks. These are things that we think the FDS needs some work on, and you know, that's also, you know, open for discussion. So.
Yeah, and while we're talking about that, I'm just going to bring that up in a side window here. So. As another share. So this is what he's talking about, this FDS roadmap, and it kind of gives a little bit of the background of it, and then proposing some new constructions, some things that need to be done in the context in which to develop with, and then the road ahead is really where a lot of these opportunities lie. And you'll see here, you know, recommendations for these potential research topics. And so you can, you know, if you're a PhD student or master, somebody working or academia or even an industry partner, finding one of these and taking them and running with it. I was going to ask you, how much does that correlate? How well does that correlate to contributions? Have you seen people say, hey, I saw this on the roadmap and I really wanted to do this and it's my new thesis? You know, how often does that happen over the last 10 years, let's say?
Rarely.
0 times? One time? Yeah, because it seems like such a great opportunity. Like anybody who's in this field who wants something useful to do can pick from this menu of options.
Part of the problem, Brian, is that, you know, probably once a week I get a paper to review that's FDS related. And at that point, whether it's good or bad, I don't have the control. I can't write to the author and say, hey, I'm reviewing your paper and I want to discuss this or that. It's like the paper is done, for better or for worse. The student has graduated. We can't have any interaction at that point. So a lot of times in the academic community, the professor thinks, oh, well, the student will write a paper and then we'll go to a meeting and then we'll discuss it over beers. And it's too late then to say, you know, I've done this great thing. It's of no use to us because you've moved on. You're working at a job. There's no way that you can help us, you know, develop that idea into something practical. So definitely contact us early if you want to pursue any of these things. And often then we can tell you that, oh yeah, we've done a little bit. Here's where it is in the code, but we haven't had the time to take it to the next level. And that would be a great thing for a student to do.
Mm-hmm. Yeah, that's a great record. I mean, I know that call out to the world has been open for a really long time, and thank you guys for keeping that up to date too, and just helping to refresh it. Because I hope that as these opportunity, these informations, we have quite a few student attendees. Honestly, there's a huge number of the tickets are the student rate, and so I'm hoping any one of them listening can, maybe take one of these and run with it, or at least bring it up to their advisor, or something like to get that information out and make sure everyone's aware of it. So yeah, I'm just looking through a little bit more chat here. There's is there a way to unite all .q files when using multi-mesh instead of importing each mesh at a time and using macro scripts? I mean, I think that's just a data management question. Are there any other ideas or tips you guys have for that?
That seems like a good thing for Thunderhead to do.
Yeah, I was going to say there's very much an idea we have about like post-processing and analysis tooling and stuff that, we're already working on results visualization and stuff, but also data management and project management and a lot of things that go on around just running the calculation. There's
I wrote this little thing called FDS to ASCII 20 years ago, and I rarely use it. More often I'll use a MATLAB script or something else if I really need to dig into one of those files. So that's also ripe for the picking. If someone wants to come up with something, that's better than FDS to ASCII.
Right. I think there's opportunities already in that, and we've even introduced in the last version of Pyrosim this run cloud capability where we have this partnership with CFD FEA services, and you can in Pyrosim put in your API key and say run cloud, and it sends a job up to this computing resource, and it, you tell it how many memory, how many CPUs you want, and how much memory, and you say go, and it starts running a job, and you can go check on it. But that whole workflow of pre-processing, generating your stuff, sending it somewhere to generate a ton of output data, and then dealing with that output in a sane way, and not just pushing it around the globe over the internet is it's a problem. It's something where I think good solutions are coming up all over the place for that.
Yeah.
So, any parting thoughts, any ideas before we kind of wrap here? Maybe I'll just call you out, maybe one at a time, just your final thoughts. So we'll start in my view of the world. There's Dave, Kevin, Simo, Jason, me, and Randy. So we'll just kind of go through it in that order. So David, do you have any thoughts or questions or ideas you want to part with?
No, this was great. It was definitely a nice technical discussion from the consulting side. I took a lot away from it. I'm definitely most interested and looking forward to pursuing more complex geometry. Kevin, your talk yesterday about the more refined and optimizing the mesh and hopefully getting away from our traditional looking models is going to be a huge impact in the consulting. Of course, I have tricks and tips to make it look more visual appealing, like overlaying a Revit model thanks to Thunderhead's product. But of course, in the background, I know what it really looks like, and that's a big thing. The consulting side, just making it look realistic while still, of course, maintaining the validity of the model. So I'm looking forward to that.
Yeah, great. Maybe Kevin, I'll come to you last. I'll give you the last word. So Simo.
Thanks for inviting to this panel. I have maybe a comment to Kevin about this university side. I have been at university for 6 years now, and now I have noticed that things that I wrote to the roadmap years ago, where some of them were quite ambitious. There are still now PhD students that have been working on some of those topics that I thought as a single project. So they were a little bit demanding, I would say. High expectations. So could be good to split them into smaller pieces.
Yeah, I was going to ask you if maybe the solution was decomposing that into more bite-sized, like paper worth instead of a whole new feature set or something. So
right.
But I did see that there are smaller projects now. It's not just like handle this whole thing that's hard. Now it's like these 3 things maybe can contribute.
Yeah.
So. But that's a good idea. Maybe feedback for the roadmap is to see if those can be decomposed into like, well, first you need to do this, and then you could build on it with this, and then you can do that. So break those down a little bit more. I was almost thinking of like, are there issues in the FDS issue tracker that match the roadmap of like feature requests that if you were to do it, what would you need to get done? And then you could almost assign those issues to somebody to contribute to or something. So anyway, yeah, thank you, Simo, for being here too, and David. Jason?
I think one of the things I like that people have a takeaway is, try and be engaged with us, especially if you're working with FDS as a student. Sort of echoing Kevin's comment, we get papers of students who have done nice experiments that they write a paper on. Some of these are great things that we would love to pull into the validation guide, but by the time the paper gets published, we've got little hope of sort of being able to work with someone at that stage to to pull those things in. So definitely we're not going to steal your thunder. We're not going to take your credit. We would like an opportunity to have a discussion with you as you're working on things, so that we're in a position to use all the great work that you're doing. Somehow in our repository.
Yeah, I mean, ultimately, how much more value is there to not only did I write this paper, but now look at this feature that everybody in the world's using in FDS. Like, there's a real transfer of that work into something practical that the world could use. So that's great. Thanks, Jason, for that and for being here today. Randy, and I just wanted to give you guys a heads up. We're a little over into the break now, so people are maybe coming and going, but we'll just kind of wrap it up and finish here. So Randy?
Okay. First, thank you very much for having us, and thanks everybody for being interested and engaged, and thanks for using FDS, which is makes our work mean something. The big picture that I see us focusing on in the short term, like Kevin mentioned a lot, wildfires. And then on top of that, there's complex geometry. I see when FDS gets released, I think getting that into shape is going to be a heavy lift. And then also modernizing SmokeView and CFast and keeping these codes going for the next generation. And I think that what's tied up in all this, and it's been kind of mentioned earlier in terms of like with the ARM architectures and things like that. I mean, we are going to stay on top of that as it becomes obvious that those are the things that we need, and for the next generation, we hope to have FDS still around as a more robust code that is, we're still, as you're going to see when Susan's talking, we're still banging away at issues like pressure solvers and boundary layer models and that's this sort of thing. But like I said, the big picture is to make keep the code robust and sustain it for the next generation. So I'll leave it at that. I'm going to also say that I'll stay on as long as anybody wants on the chat once the session closes. So I'll keep answering questions, but thank you very much.
Yeah, great. And Randy, thanks for that. And I do want to recommend anybody in here, in the chat, these discussions can carry on in the FDS discussion group. So please, as you're asking questions or you have ideas or thoughts or whatever, bring them over there. There's been a history of years and, a decade of conversation and great interaction there too. And that's been a great resource. So take them there. Kevin, last words.
Okay. And I'll follow up on what Simo was saying. And I'll address this to the professors. So I think that there's a hesitance amongst professors of students who are interested in fire modeling to bother the FDS guys. Like, I can see a professor saying, like, don't bug the FDS guys with your silly little questions. Actually, it's fine to bug us, especially if that starts up a discussion, and that discussion, can be amongst us, the student, and the professor. I think there's a hesitance. It's almost like the professor thinks, well, if we get the FDS guys involved in this project, maybe we'll have to pay them or something like that. You don't have to pay us, and we're not going to take your publications. I think it's just, I really enjoy, coming in the morning and hearing from someone somewhere, hey, I just, ran this, one of our validation cases, and I noticed that, when I change this parameter, I get a better result. And I said, that's interesting, and that might get me moving somewhere, and the student and then can kind of go along with it. And this may take like 5 minutes of my time, and the student benefits, that information then be passed along to the professor. So we got to get away from this professor-student, and that relationship has been going on for 1,000 years, right? Where you have the professor tells the student what to do, the student does it, and then graduates. I think we need to develop a different way of doing, at least, in our case, fire model development, but it probably apply to lots of other fields of engineering. So don't be shy. Reach out to us. Chances are we're working on something, but we don't have enough time, and we'd love to just pass it on to someone who's interested.
Yeah, thank you very much. And so thank you all for attending this. This has been great, great conversations. This has all been recorded, so this will be included in the archives. We'll have a roundtable. So I missed the evacuation one. I really wanted to know what was happening over there. So this will give everybody an opportunity to watch both. It'll be in the final kind of archive of the event on the FEMTC.com website. So you go to FEMTC.com/event/2020. When we have everything up there, all the talks, the roundtables, everything will all be able to be watched there. So hopefully this will get shared wide, where everybody will be able to listen to this and your calls for contribution and help with the project. So thanks again, everybody. It's been great, and hope you enjoy the rest of the conference. Yeah. So take care. Thank you.
Thanks, Brian. Bye.
Yep. Thank you. I'll stay until you're all out.
Will this be? I mean, if we leave, will the chat still be up, or?
Yeah. Gone? If you click the leave, it just kind of basically drops your audio and video out, but the chat will stay there.
Gotcha. Okay. Well, I'll take off then. Thank you, guys.
Okay. Thank you.
All right. See you.
Thanks.